All right, we're in 3.1, relationships between two categorical variables. Those two big relationships today is a response variable. The response variable measures an outcome of a study. Measures an outcome of a study. That's what the response variable does. Then the explanatory variable may help predict or explain changes in a response variable. The explanatory variable helps predict things. To me, I like the root word in that because explanatory sounds like explain. You know, you're going to explain things. This variable will help explain or predict things. We'll dive way more into that here in a second. But today on the applets, we'll be making a segmented bar chart and a two-way table. So here's what a segmented bar chart is. It displays the possible values of categorical variables. So pretty much all the way up to this point, we've been dealing with quantitative variables. Now we're switching into categorical variables. It displays that as segments of a rectangle with the area of each segment proportional to the percent of the individuals in the corresponding category. Once we see a segmented bar chart, that'll make a lot more sense. So we're just kind of putting the definitions down here. And then a two-way table, that's what that spread chart was that you just did on the activity. It's a table of frequencies or relative frequencies that summarizes the relationship between two categorical variables, groups of some individuals. So to get started, before we can really do it, we've got to kind of understand an explanatory variable a little bit better. So we're going to cheat on this and not do a lot of writing. You know, since we don't do a lot of writing for homework anyway, it's all on the computer and, you know, you just do the drop-down menus. They say identify the explanatory variable. We're going to circle that in the problem. And then the explanation, oh man, I'm going to really save us a lot of writing here for the explanation. So let's just find the explanatory variable. In number one, if the age of students, if you're comparing the age of students and whether they're allowed to stay up past 11 p.m. on the school night, there's two categorical variables there. One is the age of students. The one is, were they allowed to stay up past 11? Which one do you think helps predict the other? Like, does knowing the age help predict if you stay up past 11, or does knowing if you stayed up past 11, that could help predict the age? Which one do you think is more explanatory, age or stay up? Yeah, I would say knowing the age, you know, because it's like if you were 6 years old versus 10 years old versus 17 years old, you know, it's like that usually can help predict if you're able to stay up. So to explain that, here's what we'll do on the first one. The age predicts, you know, like if you can stay up past 11. The age predicts whether you can stay up past 11. That's probably the case. It's not always the case, you know, but it's just like more likely, statistically speaking, if you know the age of a student, you can usually predict if they're allowed to stay up past 11 or not, you know, kind of thing. How about whether a person develops lung cancer and smoking status? Smoking status means, do you smoke, yes or no, you know, and it's like whether they have lung cancer. Which one do you think would help predict the other? I would say smoking status help predicts. So here's our explanation. We are going to circle the explanatory variable, and we are going to box the other one. The other one is lung cancer, so I'm going to put a box around that. And here's how it'll be on the homework program. Like when they ask you to explain, we'll do this. Circle predicts, if I could spell, circle predicts box. And what that means to me is smoking status, because didn't we circle that, would predict lung cancer. You know, instead of writing this all out, it's like we're circling the explanatory variable. So, okay, smoking status could help predict lung cancer in that one. This is not easy at first. You know, for a newbie, it's just like, all right, you got to get used to it, right? That's why there's 5 examples here. What about the opinion about tax reform and annual income? Tax reform is basically like, how much should you pay in taxes? You know, it's like, how much should you pay in taxes? Yeah, think about it. Does the amount you take, the amount you make, help predict how much you should pay in taxes, or vice versa? Which one do you think is the explanatory variable? I got a vote already for income. What do you guys think? Do you agree with that? I think the income is definitely, it would help explain how you feel about taxes, you know? Because usually the people that make the most money hate taxes the most because they get all their money taxed, kind of thing. So we would say circle predicts box. I'll let you try 4. The average hours of study time per week and the average hours of extracurricular activities per week. Which one would help predict the other one? Circle the explanatory variable. Yeah, I would say that the hours in extracurricular activities would help predict how much study time you have. Right? So on all of them, it's circle predicts box in that situation. Circle predicts box. And then the last one, the amount of time studying for a test and the grade you received on the test. That's not always the case of true, but like which one do you think helps predict the other one? Would the amount of time you help study predict the grade you received, or would the grade received predict the amount you studied? That one's kind of fishy, don't you think? Couldn't it kind of go both ways? You know, it's like, well, it's like I got an F. That means that I didn't study, or the amount of study. I would say the studying time is the circle, and this is the box in that situation. But some of them can go both ways. We'll see that in some other lessons. It's just like, oh, that kind of makes sense. So, all right. So here's what we're going to do now. This is this cool little chart, that two-way frequency table. It says use the applet to make a segmented bar chart. So let's go to the applet. And what we'll choose is 2 categorical variables. This guy right here, 2 categorical variables. And then, unfortunately, this applet gives us some awesome information. It's going to do all of the homework for us. It's awesome. It's a lot to type in, though, man. That's the bad thing about it. So, explanatory variables, you see at the top of this chart, it is about male versus female, and it says that is their sex, you know. And then the response variable is they surveyed them about their superpower. So what this survey was, it was like, all right, they went and surveyed people. They're like, hey, if you had a superpower, would you rather be invisible, have super strength, telepathic, that means you could read people's minds? Would you rather fly or freeze time? So we'll go with this guy. We'll just put it in the same order that they were in, female and male. If you needed to add a third category, do you see the little plus? You're going to have to do this on homework. You would have to add a third category here. Response group 1, invisibility. Response group 2 is super strength. And then I got to add some more, so I got to hit this little plus. You see what I'm talking about with the little plus? So then we're going to do telepathy. Add another one, fly. Add another one, freeze time. And for the most part, you pretty much got to type all those things in to understand the graph. So then you just go put the numbers in, 15, 14. You never have to type the totals, right? Don't worry about the totals. It does that for you from what I've seen. I could be wrong about that, but I don't think so. You don't need the totals. 36, 6, 32, 20. The thing I would double check is, did you put all the numbers in the right place? Did you make any typos? The technology is going to do all the work. We just need to do our part and double check things. And then hit begin analysis like we do. And this is what's called a segmented bar chart. We will have a drop down to do other things. If we wanted to do a side-by-side bar later, you could see that. But today is about segmented bar charts. So there's that. So let's see what this guy says here on our practice sheet. It says, like, use the applet to make a segmented bar chart to look at the data of these 200 students in the UK. It says, based on the graph, is there an association between what gender you are and your superpower? Well, obviously now we don't know how to read a segmented bar chart, but I would just ask you to kind of guess. do you think there is an association? Does, like, being male, is there a way, like, if you knew someone was male, could you predict what their superpower was based on this and what they chose? Being female, could you predict what their superpower was? Is there an association between the sex of the person surveyed and what their response was in that one? What do you think? Yeah. Yeah. Thank you. It was said that females would probably choose telepathy, right, to be able to read people's minds, and males would probably choose to be able to do what? Freeze time. So what do you think? Is there an association? That is a yes, right? So that is yes. And here's how you know the segments are not the same size. The answer is yes. If these two graphs were exactly the same, male versus female, right? Here's the worksheet. If those two graphs were the same size, then you couldn't tell anything about it. So we'll write down the definition of association and talk more about it while you're writing. There's an association between the two variables if knowing the value of one variable helps us predict the values of the other. Like, if we knew the person was male, then we could predict that they wanted to freeze time, according to that data. If we knew that the person was female, we could predict that they wanted to read minds. You know, that's what that means. There's an association. If you know the value of one variable, like male versus female, then that can help us predict the other value. If knowing the value of one variable does not help us predict, then there's no association, which we'll kind of see that shortly. But association, here's the gist of it. If the segments are not the same size, like back here, you see how the two dark blues, the invisibility, are very much the same size. They're only off by 0.2%. Knowing male versus female doesn't give us any clue on, like, who's going to say invisible or not. But versus the super strength, that makes a big difference, versus the telepathy is a big difference, and et cetera. All right, so let's try a little more with that. I want you to just scroll down. Well, hold on, we'll do that something else. Let's go back to the next problem. So think about it. What would the segmented bar chart look like? I just want us to put a note right here, you know, so when we're looking back, if there was no association, the bars would be exactly the same. The bars would be exactly the same. If there was no association between sex and superpower, then the bars would be exactly the same. Or in anything, whatever you're studying in your categorical variables. So here's another one. Was there an association between your class, you know what I mean by class, like first-class citizen, second-class citizen, and third-class citizen, back in the day on the Titanic. Titanic was well over 100 years ago. That was in 1912, you know, so they had all those class systems. Your very rich were first class, your average person was second class, and then you had your third-class people. Was there an association between the class and if they survived the shipwreck, you know? So here's this. To me, that's hard to read. You know, it's like, all right, you can see the numbers, but I would much rather see the segmented bar chart. So let's take this guy and go to the applet and make a segmented bar chart about him. Right? So I'm going to just be here, and you just reset everything and hit OK. And then the explanatory variable, if I flip my paper over, is class of travel. So we'll just put class, or spell it right. The response variable is if they survived, survival status. I can't spell or type today, survival status. And then you could type all that stuff in. Bless you. So group 1 is first class. I'm just taking the chart and just literally repeating it, second class. And then I have to add one for third class, so I hit the little plus. And then I've learned in this very little bit of this little bit of typing these in, if I just go across instead of down, you can hit the tab button. So if they survived, I'm going to hit tab and go with 197. I'm going to hit tab and go with 94. I'm going to hit tab and go with 151. And then I'm going to go down to died. Poor people, they died. Just like Jack. Have you guys ever seen the movie Titanic? It's old. 25 years ago. And hit begin analysis. What do you think? Is there an association between class, if you're first class, second class, third class, and survival? Does knowing what class a person is affect their survival rates? What do you think? Is there an association? Big fat yes. Who most likely survived? The first class people, right? So, but to go back to these questions here, they ask us these things. What percent of first class passengers survived? Well, we could have done that without the applet, because all you do is, you got to be talking about a first class passenger. Aren't there 197 first class passengers that survived out of a total of 319? So we can do that real quick. 197 out of 319. Let's punch that in a calculator and round it to the nearest tenth of a percent. 197 divided by 319. So I got to move the decimal like 2 places and then look at the third place. See that 7 is got that 5 next to it, so it's going to be about 61.8%. I got to round that up. Wow. What percent of third class passengers died? Third class passengers, oh, they got to die though, so I got to do this one. So third class, 476 out of 627. If you punch that in, about 75.9%. Has anyone figured out a faster way to figure those out? If yes, you could also scroll down on your applet and look at those summary statistics, and do you see, like right here, this is how many survived, wasn't it, the 61.8? This is the how many died, 75.9. So, hey, yo, when you get these weird percent problems in your homework today, what it's trying to tell you to do is put the data into a 2-categorical variable applet and run this analysis. It will make the segmented bar chart and do all the math for you right here in the percent. Cool? So the bad thing is you just got to type it all in. So was there an association? Oh, yes. If they ask you to explain, it's because the bars are not the same. The bars or the segments are not the same size. The green information, I don't care if you write that down or not. I just kind of like to make sense of this. Knowing the class of travel can help us predict survival status. Like, that is totally why there's an association. If you knew if they were first class, second class, or third class, if you had to gamble on it, you would be better off knowing that. It's like, all right, I'll bet first class people, they probably survived. If they were a third class passenger, odds are they did not survive the shipwreck of the Titanic. Is that okay? One last one. It's a weird one. Oh, my bad. Let me talk about like the causation versus this. So here's a caution that we've got to do throughout the chapter. It may be true that a high-class travel person on the Titanic increased the passenger chance of survival. There isn't a cause and effect relationship between those, though. Here's a different example. Recent study proclaimed that people who are overweight are less likely to die within a few years than people who have normal weight. Huh? People who are overweight are less likely to die within a few years of people of normal weight. Does that mean that gaining weight will let you live longer? Not at all. The study included smokers, and you'll find out if you do smoke or you know people who smoke, smokers are usually thinner than other people because instead of eating, they smoke, you know. So, like, they're usually thinner, but since they're thin and they smoke, they probably die a little faster than other people because of cancer and things like that, you know. So don't confuse association with cause and effect. Being like skinny doesn't necessarily mean that you're going to live longer, kind of things. Does that kind of make sense, you know? So we'll get into that later. Let's do the squirrel one for the last one. Before we punch it all into the chart, it's just kind of like, what is it about? So, like, here's what's going on. They're at a park, right? And what happens was people are sitting on a bench, and they wanted to know what happens if, like, a little baby squirrel came up to them or an adult squirrel came up to them. So like, did the baby squirrel approach the people on the bench? They were indifferent, they just didn't care about you, or did they run away in this situation? Same thing with the adult. Would you please take this data right here and make a segmented bar chart in the applets? Please pause the video, get that done. Did your segmented bar chart look like that? What do you think? Is there an association? Yes or no? You will say yes if the bars are different. You will say no if the bars are exactly the same. Is there an association? We might even make a note of that, you know. You would, sorry, get out of the way. You would say yes if the bars are different. So that way when we take our quiz later, yes if the bars are different. By the way, this quiz will be after spring break. Yes if the bars are different, and no if the bars are exactly the same. There would be no association if the bars are exactly the same. So what do you think? Are those bars exactly the same? Is the dark blue, the light blue, and the orange exactly the same, or are they different? They are different. They're freaking close to exactly the same, though. Would you agree? They are so close. But what do you think? Yes or no? Is there an association? The bars are different. The bars are different, so yes or no? Yes. Yes. Even though it's so close, would you believe, since blue is approach, a baby squirrel is a little more likely to approach you than an adult squirrel and stuff like that, you know? So it just takes some getting used to, guys. It's really weird at first, you know? When I saw that for the first time, and I have a math degree, I would have said, I don't think there's an association. And it's like, no, there is an association, because there got to be exactly the same bars side by side. You know what I mean? So, all right, that's enough. Let's try today's homework.